be talking about molecular versus empirical formulas. So before I get into this video, I just wanted to say, guys, please follow me. I know a lot of you guys are liking and saving, which is amazing. But also, please follow here and on YouTube. Go to the top of this page, click YouTube, click subscribe, and help your girl out. Also on YouTube, I don't know if there was a confusion, but I just wanted to say it. If you go to my page on YouTube and you click playlist, you have different courses, and so you have all the videos that I made for that subject. And again, I'm a pre-med student. I made a 4.0 in all my prerequisites, and so I definitely know what I'm talking about, and I definitely can help you guys hopefully succeed in your own classes. So I'm giving you my tips and tricks. So again, if you want more content like this, please follow. Okay, let's get into molecular versus empirical formulas. So I know at first it can be like, well, what is a molecular? What is the empirical formula? But molecular, it just tells you the amount of atoms that you have specifically within a molecule. And then empirical is going to give you the actual ratio, but it's using whole numbers. So it's not going to be like 1.2 of carbon and 2.8 of hydrogen. No, it literally whole number ratios. And so I wanted to work with a couple examples with you guys just to introduce you briefly to the idea. So if I have, for example, H2O, I'm telling you that I have in the molecular that I have 2 hydrogens and I have 1 oxygen. Now, is this molecular formula also the empirical formula? Yes, because you cannot reduce it anymore. So in the case of water, it would also be the empirical formula. Now let's do one that is not the case. So let's say you have glucose. And for many of you, if you don't know, glucose is C6H12O6. So that would be actually the molecular formula. So for glucose, just remember, so this is actually telling you for the molecular formula that you have 6 carbons, 12 hydrogens, and 6 oxygens. That is what this formula is saying. Again, that is the molecular formula. But with the empirical formula, what you can do is you can actually say this C6H12O6, all of them have are multiples of 6. So I can reduce this whole thing by 6, and I can say, well, you can have CH2O. So for every 2 hydrogens, I only have 1 carbon and 1 oxygen. So my ratio is 1 to 2 to 1. I mean, I would write it like this, but I just want you to see it's doing the actual ratio. It's not telling me this is glucose. It's just saying that this is the ratio between the carbon, the hydrogen, and the oxygen. So going and giving you another example, if I have C3H6O3, again, I just made this up, but again, it would just be CH2O. This is again telling me the ratio. It's not telling me the actual molecule, respectively. So another example would be NH2. And in this case, it's like the beginning. You can't reduce it anymore. So both the molecular and the empirical formula would be the exact same. So what are the key take-home messages? Molecular formula pretty much tells you what you have inside of that molecule. So for example, in NH2, I only have 1 nitrogen atom and I have 2 hydrogen atoms. The empirical formula tells you the ratio, the lowest possible ratio. So again, with example of glucose, if you divide everything by 6, the lowest ratio would be CH2O. And yes, the molecular and the empirical formula can be the same. In the case of H2O, in the case of NH2, they are the exact same because you can't reduce it anymore. And again, the empirical is just pretty much giving you the actual ratio, molecular telling you what it actually is. If you enjoyed this video, again, please follow for more. I will make more videos on this, because I know sometimes they give you math problems to calculate the molecular and the empirical formula. and I will post that hopefully shortly. So thanks again for watching, and again, please follow.